Hey guys, Miss Miklos here, and this is your Conic review video. And as I kind of talked about in class, this test is split up into three distinct parts. The first is just going to be recognition. Okay, so if we look at the recognition here, what that means is we're going to have a variety of things, whether it's equations, formulas, or uses of conic sections, that we're going to have to determine what type of conic section is it, and our answer would be parabola, circle, hyperbola, or ellipse. So this will be a matching section, okay, where you can choose any of those four. None of the above will not be an option. I promise it's one of those four. So I'm just going to focus on a few different equations here. So this first equation, and I'm using the lightsaber today just for fun. We'll use it for the whole review. Okay, x squared equals 3y squared minus 2. Right away, I know this is not a parabola because I have this squared and this squared. And so really, before I can determine what type of conic section that is, I need to get the square terms on the same side by subtracting that 3y squared over. As soon as I get these on the same side, it's really easy for me to see that we have subtraction, so this would have to be a hyperbola. My second one here, y equals the square root of x plus 2, I can't tell what this is until I get rid of the square root. So I'm going to start by squaring both sides, and as soon as I square both sides, it's pretty evident that this has to be a parabola because I only have one variable here that's squared. Our third one, there we go, there's the 2 again. Woo, okay. I have two variables that are squared once again, but they're not on the same side of the equation. So I'm going to get the squared terms on the same side. And notice I really don't care about getting this in the correct form here. We just care what type of equation is this. I notice that these two terms are both squared and they have the same coefficient. So I'm going to say it is a circle. And last but not least, I actually gave us an easy one because I can see they're both squared and they're already on the same side of the equation. They're added together, but they have different coefficients, so this would be an ellipse. So this would be like the first few problems on our last few quizzes that we've had where you guys had to determine what type of conic section it is. In addition to stuff like this, it might have the general equation for the formula, or it might say something like, planetary orbits, or one of the other uses we talked about, and you would have to say, oh, that was an ellipse. So that's what this first section is going to look like. I personally think it's the easiest section because it really determines, or it's really dependent upon my knowledge of the conic sections, not my math ability. Part 2, I'm calling manipulation because it's going to give us some sort of equation and we need to do something to manipulate it to get it into the correct form or to find exactly what they're looking for. So yes, our good friend CTS is going to be used quite a bit in this section. So if it asks me to find the vertex of 5y equals x squared minus 4x minus 1, the fact that it says vertex already gives me a clue that this is a parabola, but I can tell because I only have one variable that's squared here. So the nice thing is my non-squared variable is already by itself. So I'm going to go ahead and group my x's together. I could see that we needed to complete this square on this problem because I had this extra x just hanging out. So I need to figure out what am I going to add in here to make this a perfect square trinomial. So I'm going to take -4, divide it by 2, and square it. So I'm going to add 4, which means I need to balance that by adding 4 to the other side as well. So I have 5y equals, just a reminder, when I factor this perfect square trinomial, I'm always taking this middle coefficient and dividing it by 2. So it'd become x minus 2 squared minus 5. My final step is to divide everything by 5 because I know I need to get my non-squared variable all by itself. So I get y equals 1/5 x minus 2 squared minus 1. So all we care about in this problem is what is my vertex. So in order to find our vertex, I'm looking inside my parentheses, and I notice we have an x here. So that means the opposite of this number is going to be the x value of my vertex. So I know my x value is 2. My y value is going to be whatever our constant is. So in this case, our vertex would be 2, -1. This next problem is asking me to find the center and radius of x squared plus y squared minus 8x plus 10y plus 7. And that should signal to me that this is a circle. So the first thing that I'm going to do, I'm going to group my x's together because I notice I have that extra x hanging out. I'm grouping my y's together because I have that extra y. And I'm going to move that 7 to the other side. So in order to complete the square, I'm taking -8, dividing it by 2, and squaring it, which would be 16. So I'm going to add that to both sides. And then I'm going to take 10, divide it by 2, and square it, which would be 25. So I'm going to add 25 to both sides. Okay, now I'm going to erase my work here. And we're going to go ahead and factor these two trinomials, perfect square trinomials. So this becomes x minus 4 squared plus y plus 5 squared equals, when I add these together, let's see, I get 41 minus 7, which is 34. So in this case, I would say the center is 4, -5, because once again, I'm looking at what variable is in there, and I'm taking the opposite of these two numbers. I know my radius is the square root of 34, which we can't actually simplify that any further, so that would be our final answer. So clearly we can see here that completing the square is very important. If you guys need more help on completing the square, please watch that video that I sent you guys before this chapter even started that was just on that fundamental skill. So in this problem, it's asking us to write it in the appropriate general form. So the first thing we need to determine is what type of conic section is this? I noticed right away we have subtraction, so I'm thinking that it is a hyperbola. So I need to go ahead, and I know that it should be x squared and y squared on one side, and I should really have a 1 on the other side, so I'm going to subtract that constant first. And now to make this into a 1, I'm going to divide everything by -36. So this would give me negative x squared over 9 plus y squared over 9 equals 1. Now, this might be an option, or it could be switched with our y squared term being first minus our x squared term. Remember that in this section of the test, it is multiple choice. There is E, none of the above. But I'm also giving you guys credit for your work on things like this. Okay, so I am definitely grading your work, and you're getting points for doing correct steps. Here's another write in the appropriate general form. And this one's tough because right away I can't really tell what type of shape this is. The things that we do know, if I was graphing this, I would be graphing the right half because it's x equals a positive square root. But I'm going to go ahead and I'm going to subtract 2. And then I'm going to square both sides. So I'm going to square both of these. So I get the quantity x minus 2 squared equals y minus 1. At this point, I can tell that this has to be a parabola. So I'm going to do x minus 2 squared plus 1 equals y, because this is the correct form for a parabola. So once again, if I have a square root, we need to do a little bit of work before we determine what type of conic section it is. The third and final portion of your test is graphing. So in this portion, the equations are going to be more in the correct form because I'm really testing your completing the square abilities and getting it into the correct form in the previous section. Okay, so here it's going to be pretty upfront, and it's really seeing, do you understand how to graph and list the correct characteristics? So on these graphs, there will be like 10 or so choices and then a choice of E, none of the above. And it will show a graph, and underneath the graph, it will say what the characteristics are. So let's just quickly graph each one specifically. If you need more help graphing, watch that particular lecture over again, just so you feel confident in the skills you need to have in order to be successful. So here we have x squared over 16 plus y squared is greater than or equal to 1. So looking at this, I would say that this is an ellipse because they're both squared. I have addition, but I have different coefficients. In fact, I'm going to write over 1. So the characteristics I would write down is our center is at 0, 0. Our x-intercept is going to be plus or minus 4, and where that comes from once again, my x term here, I'm taking the square root of this denominator. Likewise, my y-intercept is going to be the square root of the y denominator, which is going to be plus or minus 1. So now let's go ahead and sketch a graph of this. So when I'm graphing this, I'm going to start at 0, 0, and I'm going to go 4 to the right and 4 to the left, and up 1 and down 1, due to what these intercepts actually are. Now, this one's a little bit tougher because we have an inequality, but since I have this equals 2, I know that my ellipse is going to still be solid versus being dashed, and I know I'm going to have to shade somewhere. So I always plug in the center to see where we should shade, and when I plug in the center, I get 0 is greater than or equal to 1, which definitely is not a true statement. So I'm going to go ahead and graph everything that is outside of that ellipse. Okay, so everything I'm shading right now are the solutions. So if you really wanted to make sure, I could plug in any of those points, and we would see that it makes a true statement in my inequality. My second question here, x equals 1/3 y squared. I can tell that this has to be a parabola because I only have one variable that is squared. This is already in the correct form, so I'm going to go ahead. Oh, I forgot that I still have my giant pen there. Okay, let me make my pen a little skinnier. Here we go. Okay, I'm going to list out my 4 characteristics. So when I'm determining the vertex, I know that it is whatever is inside the parenthesis and then my constant. Now, I don't have anything in the parentheses, so that means my y value here is going to be 0. Since I do not have a constant, that means my x value is also 0. To determine which direction this parabola opens, I notice that it is x equals a positive value, so that means it is opening up to the right. My a value is a fraction, so I know this is going to be fatty, and my line of symmetry is y equals 0. So if I am sketching a graph here, let me go ahead and put my graph in. I'm going to begin at 0, 0. It's right and it's fat, so I'm going to go to the right and I'm going to go up 2 and to the right and go down 2. And my graph would look something like this. So once again, remember, you are not actually graphing it. You are choosing a graph that would look like this, that would have the appropriate characteristics that match whatever our equation is. Our next problem here is a hyperbola. I know it's a hyperbola because they're both squared and I have subtraction. And it's already in the correct form. So my center would be 0, 0 because I do not have anything in parentheses. My x-intercepts would be plus or minus 2. My y-intercepts would be plus or minus 5 because those are the square roots. Now the other thing I'm going to write to myself here is that this is on the x-axis, and I know I'm graphing on the x-axis because x is my positive variable. So when I get my graph out here, I'm going to go ahead and start at 0, 0 and move to the right 2, and then up and down 5. I also moved to the left 2. I just am too quick. So I'm going to go ahead and sketch out my box. Remember, the whole purpose of drawing this box is that it determines where the asymptotes are going to be, which in turn determine the width of my hyperbola. So since the x value is positive, we said we're graphing it on the x-axis, which means I'm going to start at the vertex which I plotted, and I'm going to draw a parabola to the right. And I'm also drawing a parabola that is opening to the left. And the final problem we're going to go through is another graphing one. This one, once again, I did not know I was in that. There we go. Okay. There we go. This one, we do need to do a little bit of work too, because I know I need to get rid of this square root. But the one thing I know right away is that this means I'm graphing the right side, because it is x equals a positive value. So I'm going to square both sides, and I knew I could square it right away because this right side was already isolated. And as soon as I get my squared terms on the same side, I can see that this is a circle. My center would be 0, 0, and my radius would be 3 because that is the square root of 9. So on my graph here, I'm going to start at 0, 0, and I'm going to go out 3 in all directions. But I know I'm only graphing the right half of my circle. So you guys could give me a graph that looked like that, or the graph might possibly look like this with the other half being dashed. So hopefully this gives you guys a good idea of the types of things you need to know in order to be successful on this test. It's my hope that if you guys study this information that you guys will all do great, and I'm looking forward to grading some great test grades.